Well, hi everyone, this is me doing our next update video on, let's have a look at page 236. This is the first time they introduced sets in our scheme, and it starts in year 8 and goes a lot deeper in year 9. So sets then starts off quite basic. If I just show you this book so we can talk through it together, that'll be good. So get the mouse out of the way. So try and focus that a little bit better. Remember, you've got your own book in front of you, haven't you? So try and adjust it a bit. I'm not totally happy with that. Alright, so if you can read with me then, it says a set is a collection of items or numbers. Sets are shown in curly brackets like that, and the things in a set are called the elements, or the members of the set are called the elements. Here are some examples of sets. So set A is defined as a set of odd numbers. Set B is defined as the days of the week. Set C is defined as those 3 fruits, and set D those 4 numbers. Now, n bracket A means the number of elements in set A. So odd numbers, there's an infinite number of odd numbers. Obviously they've not defined which odd numbers they're talking about. So let's say we had sort of 6 odd numbers in there in set A, then n bracket A will be equal to 6. Now this little squiggly Greek letter is a lowercase x in Greek, and it represents the universal set. What is that? It's the group of things that the elements of a set are selected from. There's a lovely little example there. Let's look at a question together. I don't like question 1, it's not very clear. I like question 2, good clear-cut number work. For each of the following sets, number 1, list all the elements, then write down the number in the set. So I'm about here somewhere. So I'll list the factors of 20. So here I go. This is question 2a. Just give it a quick demo. So this is the factors of 20. So here's set A, and that equals a squiggly bracket, factors of 20. Well, 1 times 20 makes 20, 2 times 10 makes 20, 3 doesn't go into 20, 4 does, it's 4 times 5, and 5 goes in, it's 5 fours, 6, 7, 8, 9, well 10 is a factor of 20, and of course 20 is a factor of 20. So that is the set called factors of 20. So that's part 1 done, and part 2 says give the number in set A. Well, how many factors of 20 are there? 1, 2, 3, 4, 5, 6. There you go. Is that alright? So you can do question 2, you know, B, C, D. Question 3 is worth doing. It's quite a nice little question there. What else we got? Question 4 is very, very good. Question 5 is rubbish. Question 6 is an extension question. Let me have a look. Whole numbers from 1 to 25, that's the universe. And A is even numbers, and B is factors of 18. Okay, let's just start off question 6. So question 6 is EXT. Not really, but they think it is. And the question says in question 6a, the universal set is all the numbers from 1 to 25 inclusive. A are the even numbers, B are the factors of 18. I've got to write down the elements of set A. So I want all the elements of set A, i.e. even numbers that are from 1 to 25. So this is like the universe from which these 2 sets derive their elements. Is that okay? So within this universe of numbers 1 to 25, we have even numbers, and we're going to have factors of 18. So let's just do the even numbers first. Well, that's going to be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay, so I just did that mentally. The factors of 18. 1, 2, 3, 4, 5, 6, 7, 8, 9. And now reach the halfway mark. And therefore the next factor of 18 will be 18. Alright? Then it asks you a question. C. The set C is the elements of neither A nor B. So, sorry, elements of either A or B. So some of these factors of 18 will clearly also be even numbers. And you're to write down the elements of set C and how many there actually are in set C. And for part D, the elements are both in A and B. So you can be an even number and a factor of 18, somewhere between 1 and 25. Again, it's a little bit more to think about than just listing sets. Alright, so 6 is definitely worth doing. Let's turn over. Venn diagrams is exactly where it's at. This is it. So when you're ready, what you should do is pause the video and just write some of this down. Venn diagrams are used to display sets and to show when they overlap. Each set is represented by a circle, and the universal set is the rectangle that goes around the outside of the circle. So the whole universe is this entire rectangle. That little squiggly Greek lowercase x is represented. So this is set A, whatever that is, and that is set B, whatever that is. And here in the region where the two sets overlap, we have an intersection. That is elements that belong both to A and to B. And outside here, outside these two sets, but still within the overall universe, we have elements that are not in A or in B. Okay? So you need to copy this down because this is brilliant. Again, you've got your book at home in front of you. Copy that because I can't say it any better than that. It's really, really good notes. And what I'm going to do is pause the video and start another one to actually show you how to use a Venn diagram. Alright, so I'll see you quite soon. So just to reiterate, you're doing exercise 1, question 2, 3, 4 and 6. And you're going to take the notes on Venn diagrams on page 237. Alright, so I'll put that in writing as well so everyone knows what to do. Catch you later.